What if we could rewind the cosmos to its earliest moments and witness the birth of stars and galaxies? For centuries, this has been a tantalizing mystery for astronomers. But here's where it gets controversial. Thanks to a groundbreaking new research program using the James Webb Space Telescope, JWST, scientists are now peeling back the veil of time with unprecedented clarity. This isn't just about sharper images. It's about rewriting our understanding of how the universe evolved from its chaotic infancy to the vast web of galaxies we see today. Enter the MINERVA program, a collaborative effort co-led by Danilo Marcassini, a Tufts University professor and dean of research. This initiative leverages the JWST's cutting-edge instruments to study the universe's first few 100 million years, a period shrouded in mystery. Unlike previous telescopes like Hubble, which struggled to capture detailed images of the distant cosmos, the JWST's medium-band imaging technology offers a revolutionary leap. By analyzing light across a broader range of wavelengths, researchers can now distinguish between faint, dust-obscured galaxies and actively star-forming regions with surgical precision. Imagine being able to see through a foggy window to spot a fire burning miles away. That's essentially what MINERVA enables. But here's the twist. This isn't just about better resolution. It's about uncovering hidden truths. For instance, astronomers have long debated whether certain ancient galaxies are truly quiescent, no longer forming stars, or just appear so due to thick layers of cosmic dust. With MINERVA's data, they can finally separate these possibilities. As Marcassini explains, the program will target 4 major extragalactic fields, expanding the observable area by a factor of 10. Why does this matter? Because the rarer the object, the larger the volume you need to study. Think of it as searching for a needle in a haystack, except the haystack is the entire universe. One of the program's most audacious goals is to study the cosmic dawn, the era when the first stars ignited and galaxies began to coalesce. Before this, the universe was a dark, neutral soup of hydrogen and helium. Marcassini describes this as the dark age of the cosmos. Now, using redshift, a measure of how light stretches as the universe expands, researchers can peer back to when the universe was less than half its current age. For example, a redshift of 10 means they're observing galaxies as they existed when the universe was just 480 million years old. And this is the part most people miss. Distinguishing between objects at redshift 13, truly ancient galaxies, and those at redshift 5, dust-obscured ones, is critical. Without this clarity, we risk misinterpreting the timeline of cosmic evolution. Another intriguing puzzle is the enigma of quiescent galaxies, galaxies that abruptly halted star formation and remained dormant for billions of years. MINERVA aims to map these galaxies from redshift 3, around 2 billion years after the Big Bang, to redshift 8, a mere 700 million years post-Big Bang. How did these galaxies shut off their star-making engines so early? Could it be triggered by supermassive black holes, or is there another mechanism at play? Marcassini hints that the data could force a rethink of existing models. And then there's the mystery of the so-called little red dots, faint red sources detected by the JWST. Are they supermassive black holes? Are they surrounded by gas and stars? Or are they something entirely new? Marcassini calls these the Rosetta Stones of black hole formation, potentially bridging the gap between theoretical models and real-world observations. Yet this raises a provocative question. Could these objects challenge our current understanding of how supermassive black holes grow? We'd love to hear your thoughts in the comments. Do you think these dots are black holes, or is there a hidden cosmic phenomenon yet to be discovered? As MINERVA kicks off this summer, the scientific community braces for a flood of discoveries. From the earliest stars to the origins of quiescent galaxies and the secrets of little red dots. This program promises to transform astrophysics. But one thing is clear, The universe has more surprises in store, and with tools like the JWST, we're finally equipped to find them.